Hi, we have the AP Physics 1 past paper 2021. We are discussing the section free response questions. We have the question number 1 which carry the 7 points. In this question, it shows a stunt cyclist build up a ramp that will allow the cyclist to coast down the ramp and jump over several parked cars. To test the ramp, the cyclist starts from the rest at the top of the ramp and then leaves the ramp, jump over 6 cars and land on the second ramp. Okay. Now, the H naught is the horizontal distance between the top of first ramp and the launch point. Here it is indicating the H naught. So you can say this one. This one is H naught here, and theta naught is the launching angle, mean from the where the projectile you can start, and the X naught is the horizontal distance it cover during the projectile motion. M naught is the combined mass of the cyclist and the bicycle. Okay. Now the question is, drive the expression for the distance x naught in term of h naught, theta naught, m naught, and the physical constant as appropriate. Okay. Whatever the exact shape of the ramp, mechanical energy should be conserved or is conserved. Ramp assumed frictionless since the coast down is word used. Okay. Now, according to the conservation of energy, the gravitational potential energy lost and the gain in kinetic energy because it is moving down from height to down. So potential energy is decreasing and kinetic energy is increasing. Okay. MGH naught is the potential energy at the moment start and half m naught v square is the kinetic energy gain. So m naught is cancelled, 2 should be moved here. So velocity is equal to square root 2g h naught. This is the speed at the launch, or you can say it is the initial velocity. Okay. Now initial velocity has a component that should be the horizontal component, that is Vx is equal to V cos of theta. Initial velocity in that sense when it is at this moment. So there is a horizontal component and there is a vertical component. So horizontal component is called V cos theta naught, or vertical component is called V naught sine theta naught. Okay, we have the value of V, so we can place the value of V here. So V is equal to 2gh naught cos theta naught. Same for the vertical component, 2gh naught square root sine theta naught. In projectile motion, Vx stays constant. There is no horizontal acceleration. We are casing the ideal case. There is a no air friction, nothing along the x-axis force. So the velocity along x-axis remains constant according to Newton's first law. While during the vertical motion, Vy change due to the external force, that is the gravity. Okay, we have the tool S is equal to Vit plus half At square. We shift this tool according to the vertical y-axis. So delta S can be replaced delta Y. Vi for initial velocity is initial horizontal component is equal to Vy, and G is equal to minus G, because the initial velocity is directed upward while the gravitational acceleration is directed downward. So it is therefore there is a negative sign because it is against the direction of initial velocity. Initial velocity is upward while the gravitational acceleration is downward. Okay. Now the cyclist lands on the same height of the launch. So vertical displacement is 0 from fig. You can see there is a starting point and this is the same landing point. So the point where it start to projectile or where it's land to the projectile, it's at the same height. So delta y is equal to 0. Vy, we have the value square root 2gh naught sine theta into t plus 1 by 2 minus gt square. So this is a negative factor. We can move from other side, become positive. T should be cancelled from t square. Only t is there. 2 square root 2gh naught sine theta naught over g. Now the horizontal distance is equal to, we have the tool S is equal to VIT. Okay. So this one. So we can place for the horizontal for x-axis. So x naught Vx into t. T is the same time of projectile, you can say. So value is here, while the Vx we have the value Vx, that is the square root 2gh naught cos theta. So we can place the value here. So we can adjust both values. Square root should be simple to h naught. G is cancelled. Here the value 4 h naught sine theta naught cos theta naught. We can write it in this manner: 2h naught 2 sine theta naught cos theta naught. This is the can be replaced sine 2 theta. So where here is we can change x naught is equal to 2h naught sine theta naught 2 theta naught. So this the you can say the horizontal covered by the cyclist. Now, the next part of the question, if the vertical distance between the top of the first ramp and the launch point is 2h naught instead of h naught, mean it increase the height. In There is no other change to the first ramp. What is the maximum number of the car that the stunt could cyclist jump over? Justify your answer expression drive in a part A. We have drive the part A relation, this one x naught is equal to 2h naught sine 2 theta naught. So only change is in h naught we have changed the 2h naught from here. So we replace we pick the 2 outside here, 2x naught sine theta 2 naught. It is the previous value that is equal to x naught. Now the new horizontal range is equal to the twice time of the previous. In previous case, when it is only the x naught, it allowed the cyclist to jump over 6 cars. As in provided in a given, there is a 6 car he can jump. So, okay, now the distance is 2x naught, so it allow the maximum 12 cars. So answer is 12 cars he can jump from. Now, if the height is doubled. Next part of the question, on the axis below, sketch a graph between the vertical component of the stunt cyclist velocity as a function of time from the immediately after cyclist leave the ramp to immediately before the land on a second ramp. On a vertical axis, clearly indicate initial and final vertical velocity component in term of h naught, theta naught, m naught, and physical constant appropriate take the positive direction to the upward. Okay, vertical velocity changes due to constant acceleration minus g, so the graph is straight line with the negative slope. Or if we state from this value, you can see the let's say if I remove the all the value, so initial velocity is can be drawn from here, this one. Okay, this is the horizontal component, this is the vertical component. So vertical component is directed upward. At this moment, just before striking the land, the direction of velocity is here. Now vertical component is here, a horizontal component is there. So here the vertical component is positive, it is directed upward. Here the vertical component is downward, so it is taken negative. So you can also understand from the fig, but according to the situation, we have the vertical component start, we 2gh naught sine theta naught, while the negative only with the negative sign. So the value decreases from the positive to negative because the acceleration is constant, the gravitational force is constant, it decreases is the velocity uniformly or linearly. So that's why the line is straight, slope is negative because value is going to decrease from the positive 0 to negative. So that's why there the slope line is straight line because the external force is constant, acceleration is constant, change in velocity is uniform. So that's why it is decreasing in this pattern. Okay, that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share with your friends. Okay, take care.